All right, so continuing on with the rational root theorem, we're going to do one more example. Let's look at that. So here we are. We have y equals x to the third minus x squared minus 8x plus 12. Go ahead and write that down, and let's go ahead and find the possible rational roots. So we'll go through this one together just to really make sure that we understand everything. So our constant term here is 12. Leading coefficient is 1. Great. What are our possible rational roots then? Since the leading coefficient is 1, everything is just the factors of 12. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All of those are factors of 12. The factors of 1 would be plus or minus 1. So we don't really need to write that spot because these are still just all of the possible rational roots. So to avoid confusion, I'm going to delete that. All right, now what do we do next? Go to the calculator. Good answer. So let's go to our calculator. Let's put this function in. X to the third minus x squared. Whoops. Squared. Sorry. Minus 8x plus 12. Great. Let's graph that. Okay, so it looks like I have a root at -3 and maybe one at 2. Those are both within my possible rational roots. So if I think I've got -3, +2 are both possible rational roots. So let's go ahead and do synthetic division with those. It doesn't matter in this case which one we choose first. So I'm going to go ahead and choose +2 just because it's a slightly smaller number and I like working with positive values whenever I can. Let me do 1, -1, -8, and 12. Now we can go ahead and bring this down. 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. -8 plus 2 is -6. 2 times -6 is -12. 12 plus -12 is 0. Awesome. That confirms we know x equals 2 is one of our roots. Now, this is a really cool thing that I'm going to show you. We haven't seen this yet, but if we find a root and we want to go ahead and test something else, we don't need to test it in the original polynomial. So notice that our reduced polynomial would be x squared plus x minus 6. Now this is also something that I could factor. So I do want to point that out. At this point, we have a lot of options. I could factor this. I can think about what multiplies to -6 and adds to 1. So if you want to go ahead and do that, you can. If it wasn't factorable, we could do the quadratic formula or complete the square. But since I already found one of my other possible roots being -3 from the calculator, I'm going to go ahead and I'm going to do synthetic division again. Whoops. -3, but I'm going to use the coefficients of this polynomial. And we maybe can already see, if we understand how this polynomial would factor, what this is going to do. So I'm going to bring down the 1. -3 times 1 is -3. 1 plus -3 is -2. -3 times -2 is 6. And that adds up to 0. Perfect. Whoops. Sorry about that. Now, what's our result? Our result is the polynomial x minus 2. Why is it x minus 2, you might ask? Good question. Remember that here we were dividing with x squared plus x minus 6, so the degree was 2. Therefore, my result has a degree of 1. Remember, we go down by 1 degree each time. Now, I can also see that if I set this equal to 0 and solve, I get x equals 2. Again, we also confirmed that -3 was a root as well. But wait a minute, we already got x equals 2. Well, let's look back at our graph, and I can see, oh wait, it looks, I guess, like maybe there's a bounce here. right? And now I'm going to zoom in real quick. So let's change this to 1, 3, -1, and 1, so that we can actually see what's going on here. And boom, I can see that bounce right at 2. So that confirms that I have 3 roots. All 3 of them are real, but one of them has a multiplicity of 2. So my roots are x equals -3, x equals 2, but this also has, oh, that's a really sloppy 2, a multiplicity of 2 as well. And remember, multiplicity just means that it occurs more than once. So in this case, it occurs 2 times because of the 2. It's a coincidence that it has a multiplicity of 2 and the value is 2. All right, so conclusion. Possible rational roots of a polynomial are the factors of the constant term, remember that is the term without a variable, divided by the factors of the leading coefficient. And remember the leading coefficient is the number in front of the variable with the highest degree. There is your homework.